GCD and LCM. Let A and B be two integers. An integer j is a common divisor or common factor of A and B if j is a divisor of both A and B. The greatest common divisor or greatest common factor of A and B, written GCD AB, is the largest common divisor of A and B. Let's look at an example. Let A equal 6 and B equal 15. The positive divisors of A are 1, 2, 3, and 6. The positive divisors of B are 1, 3, 5, and 15. Therefore, the positive common divisors of A and B are 1 and 3. For each positive divisor, there is a corresponding negative divisor. So a complete list of the divisors of A are 1, 2, 3, 6, -1, -2, -3, and -6. And a complete list of the divisors of B are 1, 3, 5, 15, -1, -3, -5, and -15. Therefore, a complete list of the common divisors of A and B are 1, 3, -1, and -3. We can write this more briefly as ±1, ±3. We see that the largest common divisor of A and B is 3. That is, the GCD of 6 and 15 is equal to 3. Another example, GCD of 2 and 3 is equal to 1, right? Because the divisors of 2 are ±1 and ±2. The divisors of 3 are ±1, ±3. So the common divisors of 2 and 3 are plus and minus 1. More generally, if P and Q are prime numbers with P not equal to Q, then the GCD of P and Q is equal to 1. Another example, GCD of 4 and 15 is equal to 1. Right? The divisors of 4 are ±1, ±2, ±4. The divisors of 15 are ±1, ±3, ±5, ±15. So we see that the common divisors of 4 and 15 are plus and minus 1. Observe that neither 4 nor 15 is prime, and yet their GCD is equal to 1. This is because 4 and 15 have no common factors except for 1 and -1. We say that 4 and 15 are relatively prime. Note that if P and Q are prime numbers with P not equal to Q, then P and Q are relatively prime. This example shows that two positive integers can be relatively prime without either integer being prime. Let's try an exercise. For each of the following, find GCD AB. Are A and B relatively prime? Now's a good time to pause the video, try this exercise yourself, and then resume the video to check your answers with mine. First one, A equals 17, B equals 51. Okay, the GCD of 17 and 51 is 17, because 17 is the divisor of 51. So 17 and 51 are not relatively prime. The GCD of 75 and 90 is 15. Right? The divisors of 75 are ±1, ±3, ±5, ±15, ±25, and ±75. The divisors of 90 are ±1, 2, 3, 5, 6, 9, 10, 15, 18, 30, 45, and 90. So the common divisors of 75 and 90 are ±1, 3, 5, and 15, showing that the GCD is 15, greatest common divisor, 15. So 75 and 90 are not relatively prime. GCD of 19 and 31 is equal to 1, right? Because 19 and 31 are prime. So 19 and 31 are relatively prime. The GCD of 170 and 483 is also 1, right? The divisors of 170 are plus minus 1, 2, 5, 10, 17, 34, 85, and 170. The divisors of 483 are plus minus 1, 3, 7, 21, 23, 69, 161, and 483. So the common divisors of 170 and 483 are just plus minus 1. So 170 and 483 are relatively prime. An integer k is a common multiple of a and b if k is a multiple of both a and b. The least common multiple of a and b, written LCM AB, is the smallest positive common multiple of a and b. Let's look at an example. Let a equal 6 and b equal 15. The multiples of a are plus minus 6, plus minus 12, plus minus 18, plus minus 24, plus minus 30, plus minus 36, and so on. The multiples of b are plus minus 15, plus minus 30, plus minus 45, plus minus 60, and so on. Notice that I've highlighted the common multiples. So the common multiples of a and b are plus minus 30, plus minus 60, plus minus 90, plus minus 120, and so on. It follows that the smallest positive common multiple of a and b is 30. So LCM of 6 and 15 is equal to 30. Let's try another example. The LCM of 2 and 3 is 6. Right? Because the positive multiples of 3 are 3, 6, and so on. 6 is the first number in this list that is also a multiple of 2. More generally, if p and q are prime numbers with p not equal to q, then the LCM of p and q is equal to p times q. The LCM of 4 and 15 is 60. Right? Because the positive multiples of 15 are 15, 30, 45, 60, and so on. And 60 is the first number in this list that is also a multiple of 4. Observe that neither 4 nor 15 is prime, and yet their LCM is the product of 4 and 15. This is because 4 and 15 are relatively prime. That is, the GCD of 4 and 15 is equal to 1. In general, if a and b are relatively prime integers, then LCM AB is equal to the product a times b. Let's try another exercise. For each of the following, find the LCM of a and b. Once again, you should pause the video now, try this exercise on your own, and then resume the video to check your answers with mine. Okay, the LCM of 17 and 51 is 51 because 17 is a divisor of 51. The LCM of 75 and 90 is 450. Here we see that the positive multiples of 90 are 90, 180, 270, 360, 450, and so on. 450 is the first number in this list that is also a multiple of 75. The LCM of 19 and 31 is 19 times 31 because 19 and 31 are relatively prime. And this is equal to 589. The LCM of 170 and 483 is 170 times 483 because 170 and 483 are relatively prime. And this is equal to 82,110. GCD LCM Fact 1. Let a and b be positive integers, then GCD AB times LCM AB is equal to the product A times B. Let's look at an example. The GCD of 4 and 6 is equal to 2. The LCM of 4 and 6 is equal to 12. So GCD of 4 and 6 times LCM of 4 and 6 is 2 times 12, which is 24, and that's also equal to 4 times 6. We now extend the definitions of GCD and LCM to larger sets of numbers. Let X be a finite set of integers containing at least one non-zero integer. The greatest common divisor of the integers in X, written GCDX, or GCD A1, A2 through AN, where X is equal to the set consisting of A1, A2 through AN, is the largest integer that divides every integer in the set X. The least common multiple of the integers in X, written LCMX, or LCM A1 through AN, is the smallest positive integer that each integer in the set X divides. For convenience, if X contains only 0, we define GCDX equal to 0 and LCMX equal to 0. Also, the integers in the set X are said to be mutually relatively prime if GCDX equals 1. The integers in the set X are said to be pairwise relatively prime if for each pair AB in X with A not equal to B, GCD AB is equal to 1. Let's look at an example. GCD of 10, 15, and 35 is equal to 5. And LCM of 10, 15, 35 is equal to 210. You may want to take a moment and pause the video and do these computations yourself and make sure that yours agrees with mine. Then resume the video to continue. Another example, GCD of 2, 3, and 12 is equal to 1. And LCM of 2, 3, and 12 is equal to 12. Notice that here, 2, 3, and 12 are mutually relatively prime, but not pairwise relatively prime, because, for example, the GCD of 2 and 12 is equal to 2, which is not equal to 1. Another example, GCD of 10, 21, and 143 is equal to 1, and LCM of 10, 21, 143 is equal to 30,000 and 30. In this case, we have 10, 21, and 143 are pairwise relatively prime. We have the following result. If X equals the set consisting of A1 through AN is a set of pairwise relatively prime integers, then GCDX equals 1 and LCMX is equal to the product A1, A2 through AN. Also note that a set of pairwise relatively prime integers is mutually relatively prime. An example. For a set X with just one element A, GCD of A is equal to A and LCM of A is equal to A. In particular, GCD of 0 is 0 and LCM of 0 is 0. Let's try another exercise. Find the GCD and LCM of each of the following sets of numbers. Determine if the integers in each set are mutually relatively prime, pairwise relatively prime, both, or neither. Go ahead and pause the video now and try this exercise yourself, then resume the video to check your answers with mine. Okay, 14, 21, 77. The GCD is 7, the LCM is 462, and neither. 2357. The GCD is 1, the LCM is 210, and both. 55, 85, and 187. The GCD is 1, the LCM is 935, and we have mutually relatively prime. 300, 450, 1470. The GCD is 30, the LCM is 44,100, and neither.